Hello everyone, this is the question asked in GATE 2020 Civil Engineering Set 2. The ratio of the sum of two odd positive integers from 1 to 100 to the sum of even positive integers from 150 to 200 is. So, in this question, we have two different series, one starting from 1 till 100 and other starting from 150 till 200. And I have to determine the ratio of the sum of odd number from this series to the sum of even numbers from this series. So to solve this question, let's have a look at the useful data. So we need to understand the concept of arithmetic progression in this question. So an arithmetic progression is a sequence of numbers in which each subsequent term of it is obtained by adding up a constant term to it. That is, the difference between two consecutive terms remains the same throughout. So, for example, we have the first series in the range 1 till 100. Now, this series can be written in the following way. It could be written as 1357 till 99, because 99 would be the last odd term of the series, which can also be written as 1, 1 plus 2, 1 plus 2 times 2, and so on, where 2 would be the common difference of its subsequent terms. Now, the general term of the series can be represented as t of n equals to a plus n minus 1 times t, where a would be the first term, in this case it's 1, and n would be the number of terms, and d would be the common difference, in this case which is 2, because the difference between two consecutive terms is always 2. Therefore, the general term of this particular series can be given as 2n minus 1. And if I start putting the values 1, 2, 3 and so on, I would start generating the series. So this would be the general form of an arithmetic series. Now, the sum of the arithmetic series with n terms can be given as s equals to n upon 2 times 2a plus n minus 1 times d, where this sum series can also be written as n upon 2 times a plus n minus 1 times t, and this term is the nth term of arithmetic series, which is also is the last term. So the sum of any arithmetic series can be given as n upon 2 times a plus l, where l is the last term. So let's use this idea and solve the problem. So the first series which is given to us is in the range of 1 to 100, which corresponds to the odd series. Now the first term of the series would be 1, and the last term of the series, which is also the nth term of the series, would be 99, because 99 would be the largest odd number less than 100. The common difference would be 2. Therefore, the number of terms in this particular range can be found out using the general formula, which is given as a of n equals to a plus n minus 1 times t. Therefore, putting all the values, we get 99 equals to 1 plus n minus 1 times 2, which would give me n as 98 upon 2 plus 1, which is 50. Now we can calculate the sum of this odd series by using the following formula. S of n equals to n upon 2 times the sum of first term and the last term. Let's denote the series by s of n dash. Now here the number of terms that we calculated is 50, and the first term is 1 and the last term is 99. Therefore, the sum of the odd series would be given as s of n dash equals to 50 upon 2 times 1 plus 99, which is given as 2500. So 2500 is the sum of the odd series which is given to us. Now let's calculate the sum of the even series. So the even series is in the range of 150 to 200, which can also be written like this. So here the first term would be 150, the last term or the nth term would be 200, and the common difference would be 2. Therefore, the general form of the series can be written as a plus n minus 1 times t, where a of n would be 200. which would give me the following equation. And on solving this equation, I would get the value of n as 50 by 2 plus 1, which is equals to 26. So 26 would be the number of terms in this sequence. Now let's calculate the sum of these terms. So here the sum would be given by n upon 2 times a plus l, where a is the first term and l is the last term, and n I have found out as 26. Therefore, putting all the values, I would get the sum as 150 plus 200. So it would be 13 times 350. Let's leave it like this. Now the only thing that I need to determine is the ratio of the sum of the odd terms to the even terms, which is given by 2500 by 13 times 350. And on simplifying this, I would get my term as 50 upon 91, which matches with option C. So option C, 15 upon 91, is the right answer. Thank you.